Hey everyone, I welcome you all to this video. And in this video, we will discuss about the concept of recursive common table expressions. So we have recursive CTEs. And a recursive CTE is a common table expression that basically refers to its own self. And we will take an example to understand this better. And we will be using a piece of code wherein we will find out the factorial of a given number. We will find out the factorial of a given number, and by using this example we will try to understand what are recursive common table expressions. So I'm creating a recursive CTE by the name RCTE. So I will write with bracket open bracket close square bracket RCTE as bracket open bracket close. Inside the bracket we can write, first of all, this recursive common table expression has two parts. So the very first part is anchor query, and the second part is your recursive query. And let's join them, append them by using union all operator. So we can write union all. All right. And now we will write this anchor query and recursive query both. So I'm writing select 1 as n. So this is an anchor query that I've written. If I will execute this query written in line number 8, so you will see that this is the output. It gives only one column in the output, and the name of that column is n, and the value given in output is 1. Now let's write the recursive query. So as a part of the recursive query, I'm writing select n plus 1 from RCTE, where n is less than equal to 4. And as you all know that whenever we are using common table expression, so the common, just after writing the common table expression or definition, we have to write, immediately we need to write either a select statement or update statement or insert or delete statement, because they will be used along with all those statements. So they can be used along with all those statements, common table expressions. So I will write select star from RCTE to understand its output, that what is the output that it generates. All right, I'll further reduce the size of this output section. Fine. Let's move it a little bit. All right. So now if I will execute this entire SQL code written from line 6 to 17, so you will see that this is the output that is generated. So now we need to understand that how this output was generated. Fine. So you need to understand that, first of all, this anchor query will be executed, and whatever will be the output of this anchor query, it will be served as an input to the recursive query. So when we will execute this anchor query, you will see the output as n is equal to 1. So I'm writing here the input and output. So we had the output of anchor query. And then we will be having the output of recursive query. So we will be having two outputs. And at the very first place, the anchor query will be executed, and the output is equal to, output will be n is equal to 1. So now, since we will get the output as n equal to 1, so this output will be served as an input to the recursive query. So it will be served as an input to the recursive query. So in the very first step, this happens. And now when the value, that is n equal to 1, will be served as an input to the recursive query, so it will be checked here in the where condition whether this 1 is less than equal to 4 or not. So yes, at the very first place, this 1 is less than equal to 4. That's why n plus 1 will be evaluated. So since the value of n was equal to 1 and now 1 is added to 1, 1 is added to n or 1 is added to 1. So the output will be 2. So this will be the output of the recursive query. That is 2. Now what will happen? This 2 will be served as an input to the recursive query again. So when 2 will be served as an input to the recursive query, so again this condition will be checked, that whether 2 is less than equal to 4 or not. So yes, 2 is less than equal to 4. So again, n plus 1 or 2 plus 1 will be calculated, because the value of n is now 2. So 2 plus 1 is equal to 3, and 3 will be stored here in the output of the recursive query. Now this 3 will be served as an input to the recursive query again. And now again it will be checked whether 3 is less than equal to 4 or not. So yes, 3 is less than equal to 4. So again 3 plus 1 will be calculated. Here now since the value of n is equal to 3, so 3 plus 1 is 4. So 4 will be evaluated as the output, and this 4 will be served as an input to the recursive query again. So when that will be served as an input to the recursive query again, so again it will be checked whether 4 is less than equal to 4 or not. So yes, 4 is less than equal to 4. So again, n plus 1, that is 4 plus 1, that is 5 will be evaluated, and that 5 will be the output of the recursive query. Again, this 5 will be served as an input to the recursive query. But when this 5 will be passed as an input to the recursive query, this condition will fail, right? Because now 5 is not less than equal to 4. 5 is greater than 4. So this condition fails. And when this condition fails, so now the query will not be executed. The execution will be terminated, right? Because the condition failed. And now whatever you can see here in the output, so we have certain values. We have 1, then we have 2, then we have 3, then we have 4, then we have 5. If we will now execute this piece of code written on the on this query window, that is written from line 6 to line 17, so you will see that in the output you see all these values, that is 1, 2, 3, 4, 5. So these are all the outputs that you can see here, right? So the very first one was the output of the anchor query, then all of the outputs were the outputs of the recursive queries. So what will happen? The union of all these values will happen. And once these values are appended, this will be shown to you as the output. That's why you see the output as this. That is, these 5 values are there in the output, right? So that is how a recursive common table expression works. That is point number 1. Now, let's discuss about finding out the factorial, because in the beginning we said that we have to find out the factorial of a number. So in order to understand about the factorial of a number, I will try to explain it to you with the help of an example. So I am writing it in line number 21. So let's say if I want to find out the factorial of a number, let's say 3. So in that case, we will have to find out 3 multiplied by 2 multiplied by 1, right? So whatever number is given, you just multiply that number to all other numbers that occur up to 1, and just keep on reducing 1 from that number. So for example, right here we had 3. So we subtracted 1 from 3. So we got 2. So 2 multiplied by 3. Then if I'll subtract 1 from 2, so I'll get 1. So 1 multiplied by this number. So this whole number will give us the factorial. If let's say we had to find out the factorial of 5, so we will write 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. I mean all the way up to 1. We have to multiply like this. So this is the factorial basically, right, of any given number. So this statement written in line 22 basically tells you about the 5 factorial. This is equal to 5 factorial, while 3 multiplied by 2 multiplied by 1 will be equal to 3 factorial. So this is the meaning of factorial. And now we want to use this common table expression to find out the factorial. This is the problem statement. Now let's execute this piece of code again, written from line 6 to line 17. I'll execute it again. So the point is that in the output, we can see all these numbers. And here in this example, we have to find out factorial 5. Why? Because we have written n is less than equal to 4, right? Since we wrote n is less than equal to 4, so we got all the numbers from 1 to 5. Now, in order to find factorial 5, we will have to multiply all these numbers. So how we can multiply these numbers? So in order to multiply these numbers, we can use the concept of log function in Microsoft SQL Server. So I will remove this select statement written in line 17 because we do not want this output, which is shown to us as of now. We rather want the product of all these numbers. So how we can achieve it? We will write select exponent of sum of log of n bracket close, bracket close, bracket close. And this will give us the factorial. We can write factorial from CTE, sorry, RCT, right? So if I will now execute the piece of code written from line 6 to 17, let's see what happens. So you can see that it generates the factorial of 5, that is 120 for us, right? And if you want to understand that how we were able to calculate the product of all the numbers in a given column by using this expression, so for that purpose, you should have an understanding about how the log works. So basically, if I can explain the mathematics of this to you, so let's take an example and let's write it here. So let's say there are certain numbers. Let's consider the example of 2 numbers. So if you have m and n, and if you will take the log of these numbers, so it will become log m and it will become log n. If you will add these 2 numbers, so it will become log m plus log n. And as per the property of log m plus log n is equal to log mn. And if log mn is written, let's say this is to some, not to the natural base, let's say just to some base small a, we can consider a base. So to the base a, log m to the base a, log n to the base a. So you will get log mn to the base a. And if you will take the exponent, that is a raised to power log of mn to the base a. So this will return the product mn. And that is the aim, right? We wanted to find out the product of all the numbers in that column. So we can use this concept. This is the mathematics behind it, right? If you do not understand this, that is also fine, but you can use this expression to find out the product of all the numbers in a given column. So that's all, and that's how recursive common table expression works. And I hope you got an idea of that how the output of this recursive common table expression will appear and how we can use it to find out the factorial of a given number, right? And also, let's say if you are not interested in finding out the factorial of number 5, let's say you are interested in finding out the factorial of number, let's say 3. So you can write a number which is 1 less than 3. So the number 1 less than 3 is 2. So let's write 2 and let's see that if it returns the correct output or not. Select it and execute it. So 6 is the factorial of 3. So yes, that is being returned to us. And as of now, since we calculated the factorial 5, so I will write 4 here. So you can change the number accordingly. In place of 4, you can write n minus 1. Let's say you want to find out the factorial of n. So if any number n is considered, so just subtract 1 from it and pass that number here in place of 4. And you will be able to find out the factorial of that number. And we have discussed that how it happens, right? So also I will write that piece of code so that if you want to refer to, you can refer to it. So Control R. Let's copy this, Control C, and I will write this piece of code here as well from line 26 might be, Control V, and let's remove this product expression and let's write, sorry, Control Z, let's write select star from RCTE. Fine. So if we will execute this statement, so this is the output. So that was the output that we have discussed. So I have written both these queries here and you can refer to them. The above one will give you the factorial of 5. Here the given number we considered was 5. Let's say you want to find out the factorial of any other number. So you can subtract 1 from that number and you can place it here in place of 4. Right. So I hope this video was helpful and you got an understanding about the recursive common table expressions. We'll meet in the next session. We'll discuss about other important topics and questions. Till then, thank you. Bye-bye.